In this example, we're given sine of theta equals 12 over 13, and we're told that theta terminates in quadrant 1. Something that I want to emphasize in this problem and throughout trig, draw pictures. Sometimes just drawing the picture tells you exactly what to do. Don't try to just visualize it. Don't say, oh, I can do without the picture. Draw the picture. It's a good habit to get into before you get into calculus. In calculus, you should be drawing a lot of pictures to help you see what's going on. So let's set up that habit now in trig. We know that sine of theta is y over r. So we know that this is 12 over 13. It's in quadrant 1, so we know that y is positive. We know y is 12. We know r is 13. Let's draw it. And I drew the whole coordinate plane here, but we know it's in quadrant 1, so we don't really have to draw all the quadrants. We know that we have our angle, that this is theta, that r is 13, this is our y value, it's 12. We know this point up here is x comma 12. We know this distance here is x, and we know that that is a right angle. Because theta terminates in quadrant 1, we know that x is going to be a positive number. Our goal is to find all 6 of the trigonometric function ratios. They already gave us sine, so we have 1. We know that cosecant of theta is 1 over sine, so we know that's 13 over 12. That one's easy. All we have to do is find the other 4, and because we know the reciprocals, we really only need to find 2. In the process of finding those 2, we need x. So we use the Pythagorean theorem. X squared plus y squared equals r squared. X squared plus 12 squared equals 13 squared. X squared plus 144 is equal to 169. X squared is equal to 169 minus 44, 144. That's 25. That tells us that x is plus or minus 5. We know that x has to be greater than 0 because of quadrant 1, so that tells us that x is equal to 5. From there, we know that cosine of theta is x over r. That's 5 over 13. And that tells us that secant theta is equal to 13 over 5. Tangent of theta is y over x. That's 12 over 5. That tells us that cotangent of theta is equal to 5 over 12. And we're done. And look how basic this was. Look how simple it was. Now, one of the benefits we got is x turned out to be an integer, but it doesn't matter. Even if it was just the square root of 7 or something like that, we would just fill in that value in the numerator or denominator as need be. This problem wasn't asking for decimal numbers. If it's not asking for decimal numbers, show me exact. Keep in mind that the setup is important. Anytime that you're working these problems, if you have an opportunity to sketch a picture, sketch a picture. Write down the information as you figure it out. Show me how you get the various answers along the way. If all you do is give me a bunch of numbers, I'm going to say, you guessed, it was a nice guess, but you're not showing me work, and I don't give points for guessing.